My students of 10th standard. Nowadays we are discussing about the lesson solution, which is a chemistry portion in your science book, Unit-9. And so far we have discussed about the solution in day-to-day life. The solution in day-to-day life, for example, seawater, which is a mixture of many gases like nitrogen, oxygen, carbon dioxide, rare gases. Also, we discussed about the components of solution. There are mainly two components, solute and solvent. Solute is present always in lesser amount by weight, but the component which is present larger amount by weight is called solvent. And the process of uniform distribution of solid into the solvent is called dissolution. Then all solutions are mixtures, because mixtures only going to give solution. For example, sodium chlorine water, which is going to be a solution. At the same time, sand and water, which is not a solution but it is a mixture. So all solutions are mixtures, but all mixtures are not solution. Heterogeneous mixtures are not solutions. Then types of solution based on the number of component. Binary solution, the solution contain one solute, one solvent, that is called binary solution. Example, sugar in water. Then ternary solution, if solution contain three components, sugar, salt and water, ternary solution. Then classification based on physical state of solute and solvent, that is going to be a type of binary solution. In the tabular column it is given solid, 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 liquid, liquid, gas. Then based on the types of solvent, nature of solvent, if the solution contain water as a solvent, it is called aqueous solution. If a solution contain any liquid other than water as a solvent, it is called non-aqueous solution. Then based on the amount of solute present in the solution, it is also classified saturated solution, unsaturated solution, supersaturated solution. So saturated solution means the solution reaches its maximum solubility. That is means no more solute can be dissolved in the given amount of solvent at the given temperature. For example, 36 grams of sodium chloride in 100 grams of water at 25 degree gives saturated solution. At the same time, unsaturated solution that contain only less amount of solute compared to the saturated solution, 10 gram or 20 gram in 100 gram of water. Supersaturated solution means that contain more solute compared to the saturated solution. For example, 40 gram of sodium chlorine, 100 gram of water at 25 degree. Then concentrated and dilute solution. So the term concentrated means which contain more solute compared to the solvent. So always solvent is going to be larger proportion by weight. Solid is going to be lesser proportion. So based on the amount of solid, we are going to differentiate whether it is a dilute solution or concentrated solution. Then next one, solubility, it is nothing but it is a measure of how much of solid that is dissolved in the definite amount of solvent. Definite amount means we are taking 100 gram. So how many gram of solid is dissolved in 100 gram of solvent to give saturated solution, that is called solubility. So to find out the solubility, there is a mathematical expression. Solubility is equal to mass of the solid by mass of the solvent into 100. Some common examples are given for the substances calcium carbonate, sodium chloride and sodium iodide, like that. Then what are the factors affecting solubility? There are three important factors. One is nature of solute and solvent, and temperature and pressure. So the nature, Like dissolves likes. That means what? A polar compound dissolves readily in polar solvent. Non-polar compounds readily dissolve in non-polar solvent. Then effect of temperature. That means the endothermic process, solubility increases with increase in temperature. At the same time, an exothermic process, solubility decreases with increase in temperature. That's why aquatic animals are more in the cold region. Cold because there more oxygen is there. The solubility of oxygen is more in that region. So more aquatic animals are possible. Then effect of pressure, this is going to deals the dissolution of gas in liquid. Solubility of gas in liquid. When pressure increase, solubility of gas also increase. The same is described in Henry's law. What is Henry's law? The solubility of gas in a liquid is directly proportional to the pressure of the gas. That means pressure increase, solubility of gas also increase. Then concentration, that is nothing but the amount of solid pressure in the given amount of solvent. So then mass percentage can be calculated using the formula mass of the solid by mass of the solution into 100. So mass of the solution means it is the mass of the solid plus mass of the solvent. Then also volume percentage, the same formula, instead of mass we are using volume. Volume percentage is equal to volume of solid by volume of solution into 100. Then next, this topic now we are going to study hydrated salt and water of crystallization. Hydrated salt and water of crystallization. Hydrate mean it is a compound containing water of crystallization. Hydrate mean it is a compound containing water of crystallization. So it is called a hydrated ion, the ion that is surrounded by water molecule. The ion that is surrounded by water molecule. Normally see, ionic substances dissolve readily in water to attain saturated aqueous solution, and the ions attract water molecule which then attach chemically in certain ratio. So the ionic substances, like for example take sodium chloride. When you are going to dissolve sodium chloride in water, the ions of sodium chloride, sodium ion, chloride ions are attract water molecule attached chemically in certain ratio. So the sodium ion and chloride ions are attached chemically in certain ratio with the water molecule. This process is called hydration. This process is called hydration. That means the attachment of sodium chloride ion or ionic substance ions with the water molecule in certain ratio. And these ionic substances crystallize out, going to form like give a shape to the substance. The ionic substance crystallizes out from the saturated aqueous solution with a definite number of water molecules. So because of this chemical attachment of ions with the water molecule, chemical attachment of ionic substance with the water molecule, the substance going to gain a crystalline form, a definite number of molecule of water. So this number of water molecule found in crystalline salt, the number of water molecule found in the crystalline substance or crystalline salt is called water of crystallization. That means how many water molecules are attached to the ionic substance. How many water molecules are attached with the water molecule. That is called water of crystallization. So these type of salts are called hydrated salt. So hydrated salt means the salt which contain water molecule. The salt which contain water molecule. Then on heating this hydrated crystalline salt, so these salts are formed by the chemical attachment of water molecule. So when you are going to heat, what happens? See, they are going to lose their water of crystallization. So the water molecules are going to be released out and they are going to attain amorphous form. Amorphous means without any definite shape or form. Crystal means it is going to have a shape, it is going to have a form. But amorphous form, when amorphous form is going to be given, when the hydrated salt is going to be heated, it going to lose the water molecule and turn to amorphous. Suppose the salt is colored green, it turn to a colorless salt. Then some examples are given for the hydrated salt. Some examples are given. See table 9.3, that is blue vitriol. Blue vitriol. That is the common name. What is the IUPAC name? Copper sulfate pentahydrate. Copper to sulfate pentahydrate. Penta means 5. The copper sulfate along with the 5 molecules of water. Copper sulfate is CuSO4. CuSO4 is copper sulfate. That is anhydrous without water molecule. So when water molecule is there, it going to be normally 5 water molecules are possible. So copper sulfate pentahydrate 5H2O. Then Epsom salt, IUPAC name is magnesium sulfate heptahydrate. Hepta means 7. So magnesium sulfate with the 7 molecules of water. Gypsum, that is calcium sulfate with the 2 molecules of water, that is a dihydrate. Di means 2. Green vitriol. Green vitriol, iron 2 sulfate with heptahydrate. Iron sulfate means FeSO4. Ferrous sulfate, FeSO4 with the 7 molecules of water. The 7, that is heptahydrate. Then white vitriol, zinc sulfate with the 7 molecules of water. Zinc sulfate heptahydrate. ZnSO4. Zn zinc, SO4 sulfate with the 7 molecules of water, that is zinc sulfate heptahydrate. So these are some of the examples of salt having water molecule along with their ions, along with their salt. They are called hydrated salt. So some examples are given here. See, copper sulfate pentahydrate, CuSO4 with the 5 molecules of water, pentahydrate. This is also commonly called blue vitriol. Blue vitriol. So what is the number of water molecule? 5. There is a 5 water molecule with this copper sulfate. So water of crystallization is 5. So it's going to be blue color. The copper sulfate is going to be blue colored substance. So when this blue colored substance is going to be heated, what happens? It loses its 5 water molecule. Loses its 5 water molecule and become colorless anhydrous copper sulfate. It's going to lose the water molecule. Because of the loss of water molecule, return to be a colorless and anhydrous copper sulfate. Anhydrous copper sulfate without water molecule. So copper sulfate 5H2O, which is going to be blue in color, on heating copper sulfate and 5 molecules of water are going to be escaped. So you will get colorless copper sulfate. It is called anhydrous. Anhydrous means colorless copper sulfate. And again, if you add few drops of water to this colorless anhydrous copper sulfate, this colorless anhydrous salt again going to turn to blue color hydrated salt. Blue color hydrated salt. Or if we keep simply on the table, after some time it going to absorb moisture and turn to blue color hydrated salt. So the blue color, the crystalline form, these are obtained because of the chemical attachment of water molecule with the copper sulfate. The chemical attachment of water molecule with the copper sulfate. So this is called the water of crystallization. Then hydrated copper sulfate. First one, see the copper sulfate blue is color in the first dish, and when going to be heated, going to be colorless. And again, if you add few drops of water, again going to regain the blue color. Then next one, see magnesium sulfate heptahydrate. Magnesium sulfate formula MgSO4 heptahydrate, 7 molecules of water. This is also commonly called Epsom salt. Epsom salt. So how many water of crystallization, or how many molecules of water with the magnesium sulfate? There are 7 molecules of water. 7. So water of crystallization is 7. So when you're going to gently heat this Epsom salt, magnesium sulfate, heptahydrate, slowly it's going to lose 7 water molecule and become anhydrous magnesium sulfate without water molecule. So MgSO4 7H2O on heating 7 water molecules are going to be escaped. So anhydrous magnesium sulfate will be formed. Anhydrous magnesium sulfate. And see, first one, see crystalline hydrated salt. Then after heating it going to be a amorphous anhydrous salt. Then if you add few drops of water and allow it cool, it's going to absorb moisture and turn to hydrated salt. The next one, see hygroscopy. The next topic is hygroscopy. Hygroscopy is nothing but it refers to the quality of a substance which absorbs moisture from atmosphere. It is the quality of a substance which absorbs moisture from the atmosphere. So that's why see these substances are used as desiccants, like drying agents. So certain substances when exposed to the atmospheric air at ordinary temperature absorb moisture without changing their physical state. So these substances are exposed on air, it's going to absorb the moisture, but there will be no physical change. The state of the substance will not be turned. Suppose a solid substance means that will not turn to liquid or in gas. It's going to retain the same physical state, but it's going to absorb the moisture from the atmosphere. So these substances are called hygroscopic substances. And the property of absorbing moisture from the atmospheric air, it is called hygroscopy. The property of absorbing moisture from the atmosphere without changing their physical state, this property is called hygroscopy. And these hygroscopic substances are used as drying agent, that is called desiccants, Examples of these substances: concentrated sulfuric acid, which is going to be liquid in form and is going to expose here it's going to absorb moisture, but there will be no change in their physical state. Similarly, phosphorus pentoxide P2O5, quicklime calcium oxide, silica gel, anhydrous calcium chloride. So these substances when exposed to air at ordinary temperature, they are going to absorb moisture and will not change in their physical state. So these are the substances, hygroscopic substances. Next one property, deliquescence. So this is nothing but this is the absorption of water from atmosphere by hygroscopic solid and change in their physical state, and going to change in their physical. These are also substances going to absorb moisture. These substances also going to absorb moisture, but one thing, these substances are changed from one state to another after gaining moisture. Water molecule will turn from solid to liquid, going to turn from its physical state. Then example, so they are the substance absorb moisture from the air at ordinary temperature, absorb enough water and get completely dissolved, completely turned. Suppose solid means completely turned to liquid. So these substances are called deliquescent substances. And the property of absorbing moisture from the atmosphere and dissolving in it, that is called deliquescence. The property of absorbing moisture from the atmosphere and dissolving in it is called deliquescence. Then deliquescent substances lose their crystalline shape and ultimately dissolve. So because of the addition of water molecule, it is going to lose its crystalline form. There will be no shape. Amorphous form will be formed, that is going to be turned to liquid. So absorb water, forming a saturated solutions will be formed. So example like calcium chloride, sodium hydroxide, potassium hydroxide, ferric chloride. So these substances are readily absorb moisture when they are exposed in the atmosphere, and completely dissolve in it. So they are deliquescent substances. And what are the condition, or when the deliquescence is going to be maximum? The two conditions are given. When the temperature is very low. So when the temperature is low means what? That atmospheric air going to have more moisture, more water molecule in the atmosphere. So it's going to absorb water molecule easily and dissolve in it. Then atmosphere is humid. Humid means containing more water molecule in the atmospheric air. So these conditions going to help to turn the deliquescent substance into water, into saturated solution. Then next see here one tabular column is given which is going to describe the differences between hygroscopic substance and deliquescence. So hygroscopic substances are nothing but substances when exposed in the atmosphere absorb moisture and do not dissolve. But at the same time, deliquescent substance when exposed in the atmosphere air absorb moisture and dissolve and change in physical state. Hygroscopic substance do not change in physical state, but here change in physical state. Hygroscopic substance may be amorphous, solid or liquid, but here these substances are going to be crystalline solid. They are going to be crystalline solid. And actually see some examples of problem based on solubility and percentage by mass and volume is given. So 1.5 gram of solid is dissolved in 15 gram of water. So here the solid is given 1.5 grams solid. Water also given 15 gram of water. So they asked to find out the solubility. So what is the formula here? See, so the mass of the solid given in the sum is 1.5 gram. Mass of the solvent is 15 gram. You have to write formula. Solubility of the solid is equal to mass of the solid by mass of the solvent into 100. Mass of the solid is 1.5. Solvent 15 into 100. When you go into cancel, you will get 10 gram. Similarly, find out the mass of potassium chloride that would be needed to form a saturated solution of 16 gram of water at 303 Kelvin. And the solubility is given. What is the solubility of potassium chloride? 37 gram in 100 ml of water. So 37 gram of potassium chloride, 37 gram of potassium chloride dissolved in 100 gram water to give saturated solution. So you have to write first what is the mass of potassium chloride. So mass of potassium chloride in 100 gram of water, 37 gram. So 37 gram will be dissolved in 100 gram. What for 60? We are going to cancel. 22.2 gram will come. Then what is the mass of sodium chloride that will be needed to form saturated solution in 50 gram of water at 30 degrees Celsius? The solubility is given. The solubility of sodium chloride is 36 gram. So 36 gram of sodium chloride can be dissolved in 100 gram of water to give saturated solution. So 36 by 100 into 50, that is going to be 18 gram. Then the solubility of sodium nitrate at 50 degree and 60 degree. So two different temperatures are given. 50 degree is 114 gram and 30 degree is 96 gram. So they asked to find out the amount of salt that will be thrown out when saturated solution of sodium nitrate containing 50 gram. What is the saturated solution? That is 50 gram of sodium nitrate. 50 gram of sodium nitrate will be dissolved in 100 gram of water. So you have to find out in two steps. First step, you have to find out the amount of sodium nitrate in 50 gram of water at 50 degree. So 114 gram can be dissolved in 100 gram of water. What for 50 gram? That is going to be 57. Then at the same time, you have to calculate for 50 gram at 30 degree. That is 96 gram of sodium nitrate can be dissolved in 100 gram of water. What for 40? So when the temperature is changed from 50 to 30, you have to subtract 57 in the first result. 57 minus 48, 9 grams of salt is going to be thrown out when the temperature is decreased from 50 degrees Celsius to 30 degrees Celsius. Then problem based on the mass percentage formula I outlined. Mass percentage is equal to mass of the solid by mass of the solution into 100. Mass of the solid. Mass of the solid is 25 gram of sugar, and mass of the solution, now we are going to calculate here. See, the mass of the solution is solid plus solvent. Solid plus solvent. So solid is 25, solvent is 100. So 25 by 25 plus 100 into 100. When you are going to cancel, you will get 20 percentage of that is the mass percentage of solid in the solution. Similarly, 16 gram of sodium hydroxide is dissolved in 100 grams of water at 25 degree to attain saturation. What is the mass percentage of solute and solvent? So you have to write here the mass of solid, mass of solvent. 16 gram sodium, that is the mass of solid, 16 gram. Then mass of solvent, 100 gram. 100 gram. So what is the formula? Mass of solid by mass of solution. Mass of solid by mass of solution. That mass of solution can be written solid plus solvent. So when you go and write, you will get that is really going to be 86.21 percentage. Then find the amount of urea which is to be dissolved in water to get 5 gram of 10% weight per weight aqueous solution. Formula for mass percentage: mass of solid plus mass of solution into 100. So here mass percentage is given, that is at 10. Mass percentage is 10. They asked to calculate mass of solids, that is the amount of urea. So mass of urea you have to keep as x by the solution 500 into 100. So when you go into cross multiply, you will get 50 gram. Then problem based on volume percentage. The formula is volume percentage is equal to volume of solid by volume of solution into 100. That volume of solution can be written volume of solid plus solvent. So here what is the volume of solid? Ethanol is the solid in this sum. Ethanol is the solid. So ethanol 35 ml. Methanol. So methanol 35 ml of methanol, and the water is 65 ml. That is the solvent. So you have to write 35 as solid and 35 plus 65 solid plus solvent into 100. You are going to cancel. You will get 35 percentage volume percentage. Then calculate the volume of ethanol. So they asked to calculate the volume of ethanol in 200 ml of solution. So volume of solution is given 200 ml of solution, and volume percentage is 20%. So they asked to calculate the volume of solid. So here you have tried volume of solid by volume of solution in 100. The volume of solid ethanol that we are going to calculate. So volume of ethanol is equal to 20 into 200 by 100, that is 40 ml. So you have to go through all these sums. Also, when you are going to check the textbook evaluation. So in the textbook evaluation, see, a solution is a homogeneous mixture. What is the number of component in a binary solution? By means 2. So 2 is the answer. Which of the following is a universal solvent? Water is a universal solvent. So the other acetone, benzene, alcohols are not universal solvent. They are all organic solvent. The solution in which no more solid. So you have to underline the word no more solid. No more solid means that is going to be a saturated solution. Identify non-aqueous solution. Aqueous means water act as a solvent. Non-aqueous means other than water act as a solvent. So sodium chloride water is there, glucose water is there, copper sulfate water is there. So first 3 is not answer. So D. Sulfur in carbon disulfide. That is the answer. Sulfur in carbon disulfide. So when pressure is increased at constant temperature, the solubility of gas also going to be increased. Pressure increase, solubility of gas also increase. So this is the description of Henry's law. When pressure changes gradually, the solubility of gas also increase. Then the solubility of sodium chlorine 100 ml of water is 36. So 36 gram, that is the maximum amount of sodium chlorine 100 ml of water to attain saturation. What is given? See, if only 25 gram of salt is dissolved, out of 30 only 25 gram dissolved, how much more salt is required? So you have to separate 36 minus 25, that is going to be 11 gram is required to attain saturation. Then a 25 percentage of alcohol solution mean 25% alcohol solution mean that contain 25 ml of alcohol in 75 ml of water. Thus the solvent is going to be normally 100 ml or 100 gram. So 25 ml alcohol in 75 ml of water. C. Deliquescence is due to strong affinity to water. Strong affinity, the attracting power, the attraction of that is ionic compounds to water molecule, strong affinity to water. Which of the following is hygroscopic in nature? Silica gel. Silica means sand, silicon dioxide. In nature, silica gel. Then filling the blank, the component present in lesser amount in solution. Lesser amount, that is solid. Larger amount means that is solvent. So solid plus solvent is solution. Then example for liquid in solid type solution. Liquid in solid, that is going to be a amalgam. For example, mercury with sodium. Mercury with sodium. That is going to be a liquid in solid type solution. So solubility is the amount of solid dissolved in 100 gram. So we are taking the definite amount of solvent, that is 100 gram of solvent. 100 gram of solvent. Then polar compounds are readily soluble in polar solvent. That only described in the early paragraphs. That is like dissolves like. Chemists always refer like dissolves like mean polar compound readily dissolve in polar solvent. Non-polar compounds are readily soluble in non-polar solvent. So polar compounds are soluble in polar solvent. Volume percentage decrease with increase in temperature because of the expansion of liquid. Because of the expansion of liquid. Then you have to write blue vitriol. Blue means that going to, you have to keep it in mind. Blue means it's going to be copper sulfate, CuSO4 5H2O. Gypsum, that is going to be calcium sulfate. You have to keep in mind calcium sulfate, CaSO4 2H2O. Deliquescence, that is the property of absorbing moisture and dissolving it, changing in physical state. That is going to be sodium hydroxide. When sodium hydroxide pellets are kept on the table, it is going to absorb moisture from the atmosphere and turn to liquid. So deliquescence, NaOH, sodium hydroxide. Hygroscopy, so this is the property of substance absorbing moisture, but there will be no change in physical state. Example, calcium oxide, CaO. Hygroscopic CaO, that is a 2413. Then true or false? False. Suppose the statement is false, you have to rewrite the correct statement. Solution which contain three components are called binary. Bi means two, but here given three components. So you have to write solution which contain two components are called binary. So this is a false. First you have to write it is false and read the correct statement. Solution which contain two components are called binary. Also you can write in another form also. Solution which contain three components are called ternary solution. Then in a solution, the component which is present lesser amount is called salt. This is also false. Lesser amount is going to be a solid. Lesser amount is going to be a solid. Suppose instead of lesser, you can also write a larger amount. That's going to be solvent. Then sodium chloride dissolves in water to form non-aqueous solution. That is wrong. Sodium chloride is a polar compound. Water is a polar solvent which is going to give a aqueous solution. Aqueous solution. The molecular formula of green vitriol is MgSO4 7H2O. MgSO4 is magnesium sulfate. That is magnesium sulfate. That is not going to be a green vitriol. That is not going to be. That is going to be Epsom salt. So green, that is going to be a ferrous sulfate. So you have to write instead of MgSO4, you have to write FeSO4. FeSO4 with 7 molecules of water. Then when silica gel is kept to open, it absorbs moisture from the air because it is hygroscopic in nature. So this statement is true. Out of 5 statements, first 4 are a false statement. So you have to write false and rewrite the correct statement. Then the Roman letter 5 define the term solution. There are 9 questions. The long answers are there, and also 2 simple hard questions also there. So you have to write classwork for these question answers. So write question, underline the question, and after that write answer neatly, legibly with good handwriting. Don't scribble. Don't scribble because you are going to use this classwork for your revision. So I post answer for this short answer and long answer hard. So you have to copy it in your classwork neatly by writing the unit and topic of the lesson. Write the question neatly, underline the question, after that write answer and prepare well. Thank you. God bless you.